One of the basic principles of science is that energy cannot be created or destroyed. In order for us to receive electricity in our homes, the current must go through an intense series of processes to transform it from fuel to usable power. The energy that we receive from power lines to our homes is typically produced by collecting fossil fuels such as coal, oil, or natural gas. Fossil fuels are formed over millions of years through the decay of dead organisms and have to be extracted from deep into the earth. But scientists have figured out how to extract the stored chemical energy and transform it into electricity by using high temperatures, turbines, and electric generators. The traditional process of burning coal begins when the coal is pulverized into a very fine powder. The powder is mixed with hot air and then blown into the firebox of a boiler. Scientists found that this mixture gives the most efficiency with the most complete combustion and maximum heat output possible. Highly purified water is then piped into the boiler and turns to steam, which creates a temperature of about 1,000 degrees Fahrenheit and a pressure of about 3,500 pounds per square inch. This pressure turns a connected turbine, which then turns the turbine shaft that is connected to an electric generator. To save energy once the steam has done its job, it is then turned back into water by traveling through a condenser. The condenser uses cool water from a reservoir nearby the factory, which is usually a lake or river. This cool water cools the steam and sends it back to be used for the next cycle. Once the pressure has turned the turbine, mechanical power is then turned into electrical power. A wire or coil spins in the presence of a magnet to produce electricity. Because the wire is spinning near a magnet, there is a constant change in magnetic flux, creating a constant flow of electrons or induced current. This current then travels through a transformer and then is distributed through a power grid. Here's a basic generator setup. In this case, instead of the windmill rotor, the rod connected to the coil would be connected to the turbine. A basic way to increase efficiency is by using wires with low resistance, such as copper. But to compensate for the long distance the power has to travel, a more complex process is needed. Transformers are one of the ways to improve the efficiency of power transportation. The current has to travel a very long distance to be distributed, so it is more efficient if it travels as a high voltage rather than a low voltage. Transformers are another example of electromagnetic induction. They're set up with a system of two coils, one with more loops than the other. The current from the generator enters the transformer and goes through the first coil. The second coil has more loops than the first, so the voltage increases due to Faraday's law. An iron bar placed through the center of both coils amplifies the induced current even further because of the properties of iron. After going through this step-up station, the current has been increased and can now more efficiently travel throughout the power lines. Once it is ready to be transported to homes, a lower power level is needed for safe usage and lower costs. The current goes through a step-down transformer, where it is reduced from a high voltage to a low voltage. Step-down transformers work exactly the opposite as step-up transformers, with the power traveling through the coil with the most loops first and then inducing a lower current and the coil with fewer loops. After the final station, the power is sent through a power meter to track a home's power consumption and then available for personal use. The disadvantages of fossil fuels for energy production are that they are non-renewable and release carbon dioxide and sulfur dioxide when they are burned. Scientists have been working on new ways to harness nature's power and use it to our advantage. One way they can do this is by utilizing the toxic gas that is released in a landfill. The trash buildup in landfills decomposes and produces a gas that contains about 50% methane gas. Normally, this byproduct is burned and destroyed, but through a series of steps, it can be used as a substitute to fossil fuels. The process begins with a series of collection wells set up in the landfills. These wells are drilled into the landfill and are connected to a vacuum that draws gas in. The collected gas is piped by a low-pressured blower to clean up the system, where the sulfur dioxide and carbon dioxide are removed. After this process, the landfill gas can now be considered pipeline-quality gas and can either be sent directly to users for use as gas or further utilized for energy production. The energy from this gas is now turned into electricity the same way natural gas is. But the advantages are that landfill gas does not have to be dug up from 20,000 feet below the Earth's surface, and it is also benefiting the environment around the landfill. The only caution is that methane can be very unstable when working with, and the facilities to extract and process and purify this gas can be expensive to construct. Producers run into the same issue of efficiency with this method of power production as well. A simple gas turbine has an efficiency only of about 20 to 30%. Like coal, efficiency can be boosted with a heat recovery system. The landfill gas undergoes a combustion process to expand and do work on the turbine. These turbines have to be able to withstand extremely high temperatures, so scientists look to build a turbine that can endure as high of a temperature as possible. A high temperature would give an even greater energy output and would increase the efficiency by a great amount. This would enable the turbine to rotate the connected coil in the generator and create a longer time period of changing magnetic flux, which would lead to a greater power output.